Okay, the last type of mole conversion problem in this series and in this playlist are mold roadmap problems, which means we're going to do some multi-step stuff. Get it? Multi-step? Ah. All right, so this is what a problem would look like. It says, how many liters of gas are 3.612 times 10 to the 24th atoms of neon gas at STP? So treat this the same way that you have already been doing and I have trained you to do. 3.612 times 10 to the 24th atoms of neon, and we want to know how many liters at STP we're going to have. So what is my conversion factor between atoms and liters? Miss Levin, I don't think we have one. You're right, we don't have one, we have two. We have to get from atoms to moles first, and then we get from moles to liters. So this is why it is multi-step. To get from atoms to moles, I use Avogadro's number. And to get from moles to liters, I'm going to use, that's right, molar volume. So if you remember, Avogadro's number is 1 mole equals 6.02 times 10 to the 23rd. And then we're dealing with atoms here, and molar volume at STP, 1 mole, is 22.4 liters. So when we go to solve this, we start with the 3.612 times 10 to the 24th atoms of neon. And since I have two conversion factors, I have to make two of these dimensions. And then I place them just like I did the multi-step dimensional analysis in the previous chapters. Okay, so what that means is I look at atoms here and I look at atoms here and I put 6.02 times 10 to the 23rd atoms of neon on the bottom, 1 mole up top. And what cancels out here? Atoms, and I use that conversion factor. And then I take and I convert moles into liters. So I do that by putting 1 mole on the bottom this time of neon and 22.4 liters of neon up top. And what that does is it cancels out moles and moles, leaving liters by itself. And that's exactly what I want. So I get my liters of neon. Well, how do I put this in the calculator? Same way we've been doing. Multiply by everything in the numerator, divide denominator. So that's 3.612 E24 times 1 times 22.4 divide by 6.02 E23 divide by 1. And that's your answer. So go get your calculator. Make sure you plug this in and you practice. Watching me do it is not the same as you learning how to do it on your own. 3.612 E24 times 1 times 22.4 divided by 6.02 times 10 to the 23rd, or E23, divided by 1. Okay, so what do we get for our answer? 134.4 liters. Okay, so what we're doing here is we are moving from our, if you look back here, whoops, hold on, come back here. If you look back here, we are going from our atoms to our liters. So that means I start here where my atoms are. Okay, so this is my start, and we're going to go to liters up here. And this is my end. There is no direct drone way to get there. So that means you have to use this conversion factor, then this conversion factor. And that's exactly what we did. Okay, so we use Avogadro's number and we use molar volume. There's no direct road. You need two. And then you'll see over here again, you cancel out your atoms by putting atoms in the denominator of the first step. And then you have moles on top. Cancel out your moles by dividing by 1 mole in the next step, leaving liters, and then multiply by every numerator. Make sure you use E for the value, or the words time 10. I'm all mixed up with my words here. I'm sorry. So what you do is you use E to represent times 10 to the. Okay, and that's that EE button in your calculator. So you'll probably have to hit the second button for that. And then if you do that, you'll get your specific units to cancel out and your values to work out, and you'll get your correct answer. Okay, a second problem here. Let's see if we're good with this. How many atoms are in 89 grams of iron? Okay, so we have 89 grams of iron, and we want to know how many atoms that's going to be. Okay, so we have to get from mass, grams, to moles, and then from moles to atoms. So how do I get from mass to moles? Molar mass. So I look on my periodic table for that. And my moles to atoms, that one right there, that's going to be my Avogadro's number. Okay, so if you look at the periodic table, it's 55.85 grams per mole. And Avogadro's number is 1 mole equals 6.02 times 10 to the 23rd atoms. So let's set it up. 89 grams of iron. I have two conversion factors, so I make two dimensions. I want to get rid of grams. I put 55.85 grams of iron on the bottom, 1 mole of iron on top, and I cancel out grams and grams. Then to cancel out moles, I put 1 mole on the bottom, and I put 6.02 times 10 to the 23rd atoms of iron up top. What that does is cancel out moles, gets me to atoms, which is exactly where I want to be. And what do I put in the calculator? 89 times 1 times 6.02 E23 divided by 55.85 divided by 1. And my answer will be in atoms of iron. So when I put that in the calculator, I get 9.6 times 10 to the 23rd. Okay, so to review, we're going from grams to atoms. So that means that we are starting here in grams, and we're going here to atoms. So we have to use 1 mole over the molar mass, and each thing weighs something different because it has different numbers of protons, neutrons, and electrons and different compounds. So it's very specific on the periodic table. You can look at those videos if you need to review that. And then you multiply by Avogadro's number, 6.02 times 10 to the 23rd. When we do that, we are going to use those two values of 55.85 grams and 6.02 times 10 to the 23rd to cancel out grams and get into atoms. So to see it again, one last time, last hurrah, we start with our given 89 grams of iron. We put 55.85 grams on the bottom, and then we are left with 1 mole up top. And then we cancel out our moles by putting 1 mole of iron on the bottom, 6.02 times 10 to the 23rd atoms up top, so it leaves atoms here. And then in the calculator, you multiply by each numerator, divide denominators. 89 times 1 times 6.02 E23. This again means times 10 to the. Make sure that you use the E, not times 10 to the, because it won't keep the right orders of operation because exponents come before multiplying and dividing, and you don't want that to get messed up. And then you divide by 55.85, and you get 9.6 times 10 to the 23rd. I hope you guys learned something about atomic structure and our mole concept in this playlist. Please make sure that you watch them and practice them. Don't just watch them, practice them. Practice your calculator, practice writing it down, and then you guys will be golden. All right, ta-ta for now, everyone.